All right, well, we're going to start a new unit, and this unit is going to be a combination of things. All right, so take a look. Last year, there was some seventh grade stuff that you guys did not cover. This year, there's eighth grade stuff that we need to cover. So, what we're going to do this year is we're going to combine the two. So, we're going to look at the seventh grade stuff that you guys weren't able to cover, or maybe you covered a little bit last year in NTI. And then we're going to talk about all the eighth grade stuff that we need to deal with. So, this unit will be entitled seventh and eighth grade geometry. So, we'll take both those and put them together. Today, we're going to go back and we're going to talk about this idea of area and perimeter of two-dimensional figures. So, first off, let's talk about the difference between area and perimeter. All right, let's start with perimeter. It's the easier of the two. Okay, perimeter, we can define it as simply the distance around a figure. Okay, and when we measure perimeter, excuse me, we're going to use what's known as a linear distance, meaning, I think I've got one handy. Here it is. When we talk about a linear distance, what we're talking about is something that we could measure with a ruler. So, for example, if I'm measuring in centimeters, that's a linear distance. I'm measuring how far along a line I'm going, all right? Or, if we want to turn it over, we could take a look at, well, what are we dealing with in terms of, say, inches, all right, in that same vein. So a linear distance is something along a ruler's edge. So we could measure things, for example, we said in inches, we said centimeters, miles, that's abbreviated MI, yards, etc. And those would be the units of measure that we would use. So let's do a couple of examples here real quick. So for example, let's say I was asked to find the perimeter of the figure. We'll say figures. We'll do a couple of them. All right, so let's say we had a rectangle. So we'll draw a rectangle in. And let's say one side here is 5. And we'll say this other side is 8. I don't know. So if I wanted to find its perimeter, I simply have to find the distance around it. So in other words, if I was standing here, and let's make it, let's make it yards, 5 yards and 8 yards. So let's say I was standing here, and I were to walk around this figure, that would give me its perimeter, all right? So in this case, since it's a four-sided figure, I know that this top edge and this bottom edge, right, these two sides are the same length. So I'm going to go ahead and label it. So this is 5 yards. And that these two sides are the same length. So if this is 8 yards, then this is 8 yards. So there's two ways I could calculate this. One way would be to simply take 5, add 8, add another 5, add another 8. And if we do that, we would get 26 yards. Again, 5 and 5 make 10, 8 and 8 make 16, 10 and 16 is 26 yards. That's one way to do it. Another way to do it, say with a four-sided figure, in this case a rectangle, is to recognize since these two are the same, I could say that I've got 2 5s, and I've also got 2 8s. Of course, we'd get 10 and 16, and we still get the final answer of 26 yards. So either way, it works. Let's try another one. Suppose we had a triangle. I don't know, we'll make it a right triangle. Why not? And in this case, let's say I've got 5 inches on one side, we'll have 12 inches on another, and then 13 there for the hypotenuse. That should be a triangle we're familiar with. And we're asked again, what's the perimeter? So again, if I were to start walking, and if I was small enough to walk along 5 inches, but if I were to walk along this edge, up to this edge, and then back down again, how far will I have gone? Well, again, it's just a matter of adding that all together. So in this case, I would take 5, add it to 12, add it to 13. And in this case, 13 and 12 make 25, plus an additional 5 is 30. And again, we need to include inches, so 30 inches. Right? And there we are. The only figure when it comes to perimeter that we need to talk about, and let's make kind of a separate talking point here. We have perimeter, and perimeter is used for things like rectangles, triangles, squares, whatever. But if we're going to talk about perimeter of a circle, we got to get more specific. All right, perimeter of a circle is called circumference. All right, and this is simply the distance around a circle. So let's try and draw a circle here, and I'll do the best I can. So a circle, oh, that's not too bad. So if we've got a circle, its circumference, again, if I were to say to stand here and start walking, how far would I go to go all the way around? In order to find circumference, we need a little bit more information, because notice we don't have nice edges that we can measure, say like a triangle, to work it out. There are two different formulas that we can use if we want to find circumference, right? One of them, let me draw the center in here. One of them is to use radius, all right? So the radius is measured from the center of the circle to the edge. So I'm going to write that in. R-A-D-I-U-S, radius. And here's the formula for that. Circumference, so we're going to use C, that variable, to represent circumference. Circumference is equal to 2 multiplied by pi multiplied by the radius of our circle. All right, so that's one way to talk about circumference. So if I know that distance, and let's make something up here. Let's say it was 5. We'll say 5 centimeters. All right. Then to find the circumference using radius, I would say 2 times pi times our radius, so in this case 5. And if we were going to use, say, a calculator for the pi button, and let me change this to make it a little bit easier to read. There we go. So if we were going to use the pi button, we could do 2 times pi times 5. And notice we would round wherever we need to round to. So in this case, maybe we round to the 10th position. So we would have 31.4, and in this case, centimeters. All right, and that would be our circumference. Again, the same concept as perimeter, the only difference being circumference is specific to a circle, all right, whereas perimeter is more general, talking about other figures. There is another formula, so let me switch colors out here if I can. I think I've got a different color. There is another formula. Let me see if I can draw this in. Well, that green's not showing up very different, but it's there nonetheless. This green line that I've drawn goes from the edge of the circle through the center to the edge on the other end. We call that line diameter. Okay? And again, the diameter is twice as long as the radius. Notice a radius is half that distance. The diameter has a radius on one side and then another radius on another, so it's twice as long. So if I wanted to use the same circle, but use a different circumference formula, here's what I would do. I would say circumference this go around, since a diameter is 2 radii, I could say simply that it is pi multiplied by the diameter. And let's review. In this case, we said our radius was 5 centimeters, so that means our diameter would be 10 centimeters. And if I use that in my formula, pi times 10 in this case, and again, we can go back to our calculator, pi times 10. Notice we get the exact same answer. We'll get 31.4, what were we measuring at centimeters. So either formula will work. The question is, what do you have to work with? If you've got a radius, well, then use this formula. If you've got a diameter, then use that one. And make sure you get those down, folks. That's pretty straightforward. So that's perimeter / circumference, as the case could be. Let's talk about a new concept. This one, set that off to the side. This time, let's talk about area. Okay, we've talked about area briefly before in another video, but let's kind of hit on it again. If we're talking about the area of a figure, we're talking about how much 2D space a figure takes up. Said another way, let's say I've got a I don't know. We'll go with a rectangle. Okay. Since we're talking about two-dimensional space, not a linear distance, but a two-dimensional space, what we're doing when we look at area is we're trying to see how many squares of a particular size fit into our figure. So let's say this square represented something that was 1 inch by 1 inch. Okay. Then the area of that particular square is 1 inch square. So notice the difference. If we're talking about a linear distance, that's this, 1 inch from here to there, a distance. If we're talking about this 1 inch squared, then what we're talking about is a square measuring 1 inch by 1 inch, and how many of those would fit. So let's try that real quick. So if we were to take a square about that size and start filling these in, let's see how many we've got. And those squares are kind of squished at the bottom, but we'll count them. So let's see how many we got. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. We've got 24. So this figure is 24, we'll say, inches squared, or that's what it represents. Okay. Now, I don't know about you, but if I'm going to have to find the area of things, I do not want to have to sit there and draw teeny tiny little boxes every single time. That's very time consuming and kind of stupid. Let's do it differently. Notice that we said when we counted them up, we got to 24. So the quicker way of finding the area of that figure, watch this, I've got 1, 2, 3, 4, 5, 6 inches across this side. So let me write that in. 6 inches. And if I count down this way, I've got 1, 2, 3, 4 inches. So if I want to find the area of this figure, notice all I got to do is take the base, or sometimes referred to as the length. So I'm going to say base, multiply it by the height. So again, sometimes this is referred to as width, but we're going to call it height. So in this case, 6 for the base times 4 for the height. And what do you know? 24. And notice how we're writing our unit here. Here, for a linear distance, we could just say inches, centimeters, whatever. Here, I've got to say inches squared. Because I'm not looking at a distance, I'm looking at how many of those squares fit inside. What we need to figure out are formulas like this for our figures, so we're not having to sit there and draw. We can simply rely on our figures, all right, our formulas here. So let's write a few of them out. So for example, let's talk about quadrilaterals first. Quadrilaterals. Quadrilaterals. In other words, four-sided figures. So if you've got, say, a square, say a rectangle, parallelogram, and if you're not sure what a parallelogram is, that's where you've got two sides that are parallel, you've got two other sides that are parallel. So a lot of times they look like that. So squares, rectangles, parallelograms. Oh, there was one more. It was on the tip. Oh, rhombus. And if you're not sure what a rhombus is a four-sided figure where all four sides are the same length. However, unlike a square, they don't have to form at right angles. So maybe you've got something like that. All right, where all four sides are the same length. Of course, you know what a square is. They look like that. We know what a rectangle is. It looks like that. All of these, as it turns out, have the exact same area formula. I'm going to write it over here. Their area formula is equal, we just talked about it up here. You take the base, multiply it by the height, and you're done. All right. So for example, with a rectangle, it's simple. The base is one edge, the height is another, and you just multiply. The same works with squares. With parallelograms, this gets a little bit different. So let's try an example of a parallelogram. So let's see if we can draw one here. Oh, I'm on fire today. Look at that. Relatively straight lines and everything, and they almost look parallel. There we go. So let's find our area. So we'll write that up here. Find the area. So if we're talking about a base, say for a parallelogram, then this side, for example, could be our base. So let's say it's, I don't know, let's say it's 6 yards long, just to get a different measurement of it. 6 yards. Now height. Height is an issue. Height has to go from base to base. This does not count. Okay? If I'm going to talk about height for a parallelogram, it's got to go at a perpendicular. That's what that symbol means. It's a right angle at a perpendicular to both. So this slanted part, not the height. This is our height. So maybe we say our height here is, I don't know, we'll say it's 3 yards. Why not? All right. So if we've got 3 yards here and 6 yards there, then all we have to do again is base times height. So we'll do 3 times 6, and that would give me 18 yards, and make sure you include this, squared. Because remember, we're seeing how many squares we could put in there. And obviously in this case, we'd have to take some of those squares and cut them at angles to kind of tile it in there, to fill it in. All right. So all of these, squares, rectangles, parallelograms, your rhombi, that's the plural for rhombus, all of them follow that formula, which makes it pretty easy to remember. All right. Let's try another figure. Yeah, we got space here. Let's talk about the area of a triangle. All right. Well, areas for triangles are pretty straightforward, so let's draw one in here. I don't know, let's draw one like this. Let's draw a right triangle just to make it easy on me. So how would I find the area of my triangle? Well, let me show you something. Let me grab another pen here. Maybe one that'll write. I'm going to draw in another right triangle the exact same size as the green one. All right, so there it is. Notice if I do that, if I take two triangles of the same size and put them together, we get a quadrilateral. In this case, I got a rectangle. If I did it another way, maybe I could get a parallelogram or a rhombus, whatever. This time when I put them together, it's a rectangle. I know the area formula for a rectangle. I'm going to write it up here. Our area formula for this would be base times height. Well, notice, here's my base. So maybe this is, I don't know, maybe this is 5 meters. And maybe my height, this leg of our right triangle, wouldn't put it in this, right? Maybe this side is, I don't know, maybe it's 7 meters. Well, notice if I did base times height, that would find the area of the entire rectangle. And I don't want all of it. I just want this much. Well, notice if these two are the same size, then that means this green portion that I'm shading in has to be half. So the area formula for a triangle is as follows. We're going to take the same thing as our quadrilaterals. We're going to take base times height, and then we're going to divide by 2. Now, if you don't like the way I wrote that, let me write it a different way for you. We could also write it as area equals base times height divided by 2. So whichever formula works for you, use it. So let's try a quick example here. Maybe we've got a triangle. I don't know. Let's draw something crazy here. How about an obtuse triangle? I mean, let's really go wild. Maybe it's drawn like this. I mean, we've just got a crazy triangle here. There we go. So let's talk about our base. Maybe our base goes here, and it is, I don't know, maybe 21 inches long. So there it is, our base. Now, our height, remember, height has to be straight up and down. So what I'm going to do is from this top part, we're going to count down. And this line here, it helps if you do the noises. This would be the height of our triangle. Again, I don't want to use the slanted side. That wouldn't work. You know, for example, if I was trying to find the height of this pin, slanting it, and then counting that, no, I've got to straight up and down. So let's say my height here is, I don't know, let's say it's 18. I don't know, 18 inches. Cool. So I'm going to take base times height. So again, here's my base. Here's my height. I'm going to multiply those together and then divide by 2. So again, if you're using a calculator, let's grab one here real quick. So we said area is equal to base times height divided by 2. And in this case, base is 21. Our height we said was 18. And then we divide by 2. So when you type that in, let's clear that out. So when you type that in, just type it in exactly as you see it. 21 multiplied by 18 divided by 2. And we get 189. So let's write that in. So our area is equal to 189. And remember, we got to include units. So in this case, inches squared. So triangles are pretty easy. So long as you can find a base and a height, you're golden. It's literally base, height, divide by 2. It's over. Let's talk about the one that's tricky. And I'm going to switch pens again because this one's easier for me to write with for circles. Area of circles. Now, circles are a little tricky. Let's see if we can draw one again. Goodness gracious, don't even need to buy a lottery ticket. All my luck was gone up there. So take a look. When we find area of circles, we still need some information. And the information we're going to want is the radius. All right. So if I know the radius, I can find the area of the circle. And the area, and notice how I keep using these capital A's to represent area, whereas over here I used, for example, C to represent circumference. Just keeping that in mind. I'm using variables. That way it represents what we're talking about. So C is for circumference, A is for area. If we're talking about perimeter, we could talk about it in terms of P. P is equal to the perimeter. So our area formula in this case, and it's kind of an odd one here, is pi r square. And I know pi aren't square, they're round, but that's how I remember it. Pi r square. And we know they're not square. Pi's aren't square, they're round. I made one this weekend. So all you got to do is take that radius, square it, and then multiply it by pi, and that'll tell you how many squares of a particular size you could put inside the circle. And again, we'd have to cut some of them up to follow that edge, but again, we could fill it up with so many squares of a certain size. So let's try one. Well, why not? Let's try 2. So I'm going to make a circle here. I'm getting good at that. And a circle here. That's amazing. I'll never be able to do it that good again. Let's try this first one. So let's make our radius, I don't know, let's make it a crazy number. How about 7.5 feet? All right. So what would the area, how much space, how many of these little squares, if they were 1 foot by 1 foot, how many of them would fit inside? So our area formula is pi times the radius squared. All right. So let's take pi, and this time let's make pi 3.14 because that pi button. Remember, if you use a pi button on a calculator like this, goodness gracious, that's a lot of digits. And if you're looking for accuracy, wonderful. If you'd like to get an answer that's halfway decent to manage, we'll abbreviate or approximate rather. So let's make it 3.14 times. In this case, we said our radius was 7.5. So 7.5, and we'll square it. All right, well, let's do that. So let's take pi. We'll use 3.14 here. So 3.14, so 3 1400ths times 7.5, and we're going to square it. And my calculator here, we got a exponent of 2. We can hit enter, and sure enough, let's round it to the 10th place. So 176, and again, there's the 6, there's a 2, so we'll round down. So 176 and 6/10 feet squared. And ta-da, there's our area. So if we had 176 feet squared tiles, it would take 176 of them, almost 177, to completely fill it up. But what if? Let's play the what if game here on this last one. What if our circle didn't give us the radius? What if for our circle, they gave us a diameter? And let's assume in this case that our diameter is, I don't know, how about 22? Since that was feet, we'll use meters here. 22 meters. Well, notice our formula only allows for a radius measurement, so we're going to have to make a conversion. In this case, I've got to find what the radius is. And remember, the radius is measured from the center to the edge. That's only half the distance of the diameter. So in this case, I only need 11 meters. Let's write that in. Our radius is 11 meters in this case. Now that I know that, I can find my area. So area is equal to pi times the radius squared. In this case, we found our radius. We took the diameter, cut it in half. So we're going to take 3.14, just like we did before, multiplied by 11 squared. So let's type that in case we need to see how we do that power of 2 again. So 3.14 multiplied by, in this case, 11. And then my power of 2 button is here on the far left-hand side. Well, maybe. There we go. And we're going to see that our area for this circle is, what is that? 300. And now notice, if we're rounding to the tenths position, that's a 4, so we'll round down. So 379.9, in this case, meters squared. There we are. So those are the formulas. Make sure you've got them all jotted down. Eventually, guys and gals, you need to have these memorized. So you need to know that the area for a circle is pi r squared, or that the area for a triangle is base times height divided by 2. Or that basically for almost all of our quadrilaterals, not all quadrilaterals, but almost all of them, area is simply base times height. And then, of course, for circumference and then for perimeter, we need to know how to find those. If you've got any questions, bring them with you to class. We'll spend plenty of time practicing this, and you should be good to go. Have a good day, folks, and we'll see you tomorrow.